And so here is another, just to kind of go through the motions one more time. Again, you can see our domain. If we actually put that in for sine, if I actually put in negative 3 pi for x, notice what we would get is negative pi over 2. And if I put in 3 pi for x and I divided it by 6, I'd get pi over 2. And hopefully you remember those were what we restricted the inverse of sine to be. So again, those are why those restrictions are there. We don't really do much with them, but I wanted you to understand why they're there. So in this case, I want to still solve this equation for x. And in order to do that, I can't just divide by sine. Okay, that would be a sin. So in this case, I do want to divide by negative 5 to get that trig function by itself. So on one side, I have y over negative 5. This becomes positive 1. So I just have on my other side of my equal sign a trig function. Happens to be sine of x over 6. So what I need to do next is take the input and the output and reverse their order. And in order to do that, if I want to put the x over 6 here and keep the sign as is with the y over negative 5, I need to make sure that I tell them how I know I'm able to do that. And that's by, if I'm going to reverse the order, I got to let them know that, hey, this x over 6, which was my angle before, y over negative 5 is not my angle. They have been reversed. And then lastly, in order to solve, we know to finish, to undo dividing by 6, we'd have to multiply by 6 to both sides. So that this would cancel out, and I get x is equal to 6 times the arc or inverse sine of y over negative 5. And it is that easy. Hopefully you'll be able to differentiate between a problem like this and any of the other ones that we've seen. That's where the quizzes and exams are a little bit harder. In this section of homework and when you're practicing these types of problems, yeah, you're going to get a lot that are similar to this. But when they're all mixed in together, hopefully you can figure out when to do what. So let's take a look at a couple different other types for this that you will see. These you can see ask a little bit something different. Up above, we had problems that had both a y and an x in it, a y and an x. And so our answers when we solve for x had y's in them. Our answers had y's in them when we solve for x. Well, now if you look at this second example, we actually only have one variable, and that's x. So when they ask us to solve the equation, we know we're solving for x again. And notice I bolded it for you. They may not always do that. They're going to ask us for exact solutions, which is good for us. That means we don't need a calculator, but we do need to know our reference angles. So in this case, always, anytime you see a trig function, you want to isolate it and get it by itself. So in the second one here, we have a similar look, but this time, hopefully you notice instead of arc, they now have the negative 1, still denoting the inverse. So whether it's arc or the negative 1, you need to know that it's dealing with the inverse. And first things first, we need to always isolate the trig function first. So in this case, since it's being multiplied, I will divide by 6 to get my inverse cosine of x equals 5 pi over 6. And then at that point right there, I know that to get rid of the inverse, I actually can do what it says this time rather than us having to do it. I want to take my input and my output and I want them in reverse order. So I'm actually going to apply the inverse, which means I will now have cosine of 5 pi over 6 is equal to x. And so I found what x is equal to. I just need to evaluate. So remember, cosine of 5 pi over 6, hopefully you recognize my reference angle of pi over 6, which is what? Hopefully you all said 30. And then 30 times 5 is 150. So that would take us right here with the reference angle of 30 degrees, or pi over 6. And that therefore tells us that it's going to be negative. And hopefully you remember the cosine of 30. That is the square root of 3 over 2. So pretty simple. Be careful. You can make little mistakes here and there, but these are a lot more straightforward than the ones that we've worked on previously. So I got one last type for you to check out, and then that's it for both this section and this chapter. So hang in there, we're almost there. So this time you can see we have multiple trig functions, yet both of them have inverses on them. So remember, inverse means that we're finding angles, which means they're typically going to be listing ratios, whether they are known or not. In this case, we're still trying to solve, and you can see they want the exact solutions, which is also a good thing. No need for punching things into calculators and hoping that you're right. So if you notice on the left side, there's an unknown, a variable. In this, we actually know this number, 1/2. So in this case, I'm going to keep the cosine inverse of x, and I'm going to set it equal to the inverse sine of 1/2, because I actually know exactly the angle, which is what this is asking for sine that gives me 1/2. This would be equal to pi over 6, or 30 degrees. So I can actually replace this whole thing with what it's equivalent to, an identity, if you will. And so now, hopefully you notice this looks exactly like the previous problems that we were working on, where I would just take and actually apply the inverse, and that means to do the reverse for my input and my output. So I can now rewrite this as the cosine of pi over 6 equals x. And hopefully you know the cosine of 30, we just did it, is root 3 over 2. And so some are obviously easier than others. Because we knew this, the angle for sine that gives us 1/2 is pi over 6, we simply just replaced it and then solved for x by utilizing the inverse that's already there. You can see part B is a little bit more daunting, because on the right side, we don't necessarily know an angle, which is what this is asking, for cosine that gives us 5/13. The cool thing is, we don't need to. So I'll rewrite this as arctan, or inverse tangent of x, equals, all I know is that this is asking for some angle. And if I wanted to solve this for x, hopefully you can see right then and there that all I have to do to solve for x is reverse the order of those two things, which is exactly what this says to do. So I'm going to apply that by writing the tangent of reversing my order, that. So in order to find or solve this solution for x, all I need to know is what tangent of theta is. And if you remember, theta was derived from this side over here. And because cosine is positive in quadrant 1, I can go and draw this out over here. And I know cosine is always the x over the r. And therefore, I know that this is 5 and this is 13. And I can either use the Pythagorean theorem to find that value, or hopefully you guys already know it, because it is a Pythagorean triple of 5, 12, 13. And therefore, I didn't even need to know this angle theta, which is what this all represented, because now I can find the tangent of this value theta, which, remember, tangent is always the y over the x. So my answer for this is 12/5. So remember, if you ever are stumbling on a trig problem, drawings often help. You just have to decipher what all of this inverse stuff means and when you have what. So if you can evaluate like we did on part A on this one, please do. If you can't, draw it out. Don't feel like you have to punch that in your calculator and find the angle and then do the inverse or the tangent of it. You can find it without doing any of that pretty simply. That's all I got for you this round. Hopefully you guys are doing well with this all and being healthy, hanging in there. Let's finish strong, gang. Take care.